All right, good morning or good afternoon, right? Whenever you're watching this video. This is Mr. Collazo, and as you can see, today we are learning about discrete and continuous data, okay? So we have two different sheets, so we're gonna go with discrete first. So, the definition of discrete data, or I guess we're talking about graphs right now. So a definition would be a graph composed of isolated, so that means kind of like by themselves, of isolated points. Okay? So it is also a set of values where the values are separate. And that would mean whole numbers. Okay? So that's our definition for discrete, right? If it doesn't make sense now, hopefully when we look at some examples and graphs, it will. So if we move up a little bit, some examples of discrete data would be people, right? People are discrete. Phones, animals, buildings, and we could say masks, right? Okay, so all of these things kind of have in common is it's kind of hard, it's impossible really to have decimals of some of these things, right? So if we have people, you can't have a third of a person, right? You can't have a third of a dog, right? These are all things that they have to be whole numbers, right? We have 5 masks, we have 2 buildings, 3 phones, right? They need to be whole numbers. Now, if we're looking at a graph, so let's draw a little graph real quick. So if we're looking at a graph, a discrete graph would look like some isolated points. So it'd kind of be just dots all along the graph, right? That's what discrete data would look like. So we can also determine if discrete data or a discrete graph is a function or not. So we can give it 2 little graphs. Okay, so we could do one like this. It can be one discrete graph, and then we can have one like this. All right, so if we remember how we talked about functions, remember we used the vertical line test to determine if graphs are functions or not, right? So what we would do is we would draw like our dotted lines, right? So we draw a dotted line all through these, and they should only hit one time. So every time I'm drawing these vertical lines, I'm only hitting one point, which means this one on the left is a function, right? If I go to this right graph, if I do the vertical line test, well, right there automatically, right, it hits 2 points. So because it hits these 2 points with that vertical line, this second graph is not a function. Okay, so you can determine from a discrete graph whether it's a function or not a function, okay? Just like another graph. So let's move to continuous. Now, continuous is a little different. So let's start with the definition first. So a continuous graph, let me get that in the middle, is a graph composed of an unbroken line. That's the key word there, unbroken. Okay, so an example of that is, or not example, but it's also a set of data where values are infinite. And that would be like decimals. Okay, so let's look at some examples of those. So some examples could be, we could be talking about height. That's continuous data. Weight. Temperature. distance, and time. Right? So if we look at the examples, we can kind of see the difference, right? Discrete data, remember, those had to be whole numbers. So like 2 people, 2 phones, 2 animals, right? But this continuous data, these can be decimals or fractions, right? We can be 6.5 feet tall. We can weigh 122.5 pounds, right? The distance can be 3/4 of a mile, right? These can be broken down into decimals. And what graphs look like, so we'll do 2 examples. So a continuous graph could look like something like this, or it could even go something like this. It could be kind of weird shaped. Okay. But what makes this a continuous graph, the key thing that we can tell is because it has an unbroken line. So kind of the test you can do is if you put your pen on one side of the graph and you can trace the graph all the way to the other side, it's unbroken, right? Because I didn't pick up my pencil, so it just continuously went all the way from the left to the right. I can do the same thing here. We go down, over, and down again, right? I didn't pick up my pen. We can't do that with the discrete graph, right? Because it's dots. So I have to put 1 dot. I have to pick up my pen to go to the next dot, okay? That's what makes this discrete and these continuous, okay? And then we finish off with the functions. So just like discrete graphs, continuous graphs can be functions or not functions. So let's draw our 2 graphs. So let's say we have, let's do a little parabola again. And let's do something like this. Okay? So same thing, same rule, or the same test, really. We're going to be doing the vertical line test. So if we do vertical lines, right? Here's one vertical line. It hits at 1 point. Another vertical line, it hits at 1 point, right? I could keep drawing vertical lines, but hopefully y'all can tell this would pass the vertical line test, right? It doesn't matter how many vertical lines I draw, it's going to hit the graph at 1 point. So this left graph is a function, okay? This right graph, on the other hand, hopefully y'all can tell. If not, let's do the vertical line test. So I draw my vertical line, and I see it hits at 2 points. So automatically, if the vertical line hits 2 points on my graph, not a function. I don't have to do it any more times. Not a function. Okay. So that's the discrete and continuous data. Let me see if I can fit it all on the page. I can. Okay, so if you have any questions, ask your teacher, and I'll see y'all on the next video.